Hi guys, in this episode of Shri series, we're going to be talking about linear graphs. So we'll go through the step-by-step processes of solving each and every component required for a linear graph. Now, in the previous session, I did talk about what is the y-intercept, what is the x-intercept, and I also touched briefly on the gradient in terms of what the gradient means and the formula for calculating the gradient, all right? In today's video, we're going to be practicing some questions on how to calculate the gradients of the following pairs of coordinates. All right. So I've got three pairs here. I've got A, 4, 2 and 12, 4, B, negative 3, 4 and 4, negative 3, and C, negative 2, negative 5 and negative 4, negative 2. All right. So I did mention before that when we calculate gradients, there are two ways and two methods of working it out. So one, we've got rise over run, all right? But I also mentioned that as you are progressing from year 9 to year 10, we use another formula for calculating the gradient, all right? So the formula for calculating the gradient is right here. So m equals y2 minus y1 over x2 minus x1. So what do I mean by that? All right. So the word m or the letter m stands for gradient. All right. So when we've got two pairs of coordinates, the first thing I like to do is allocate the pair. So in other words, x1, y1, x2 and y2, you allocate them. All right. Now there's no hard and fast rule in determining which one would you want. You could put that as x1 and y1 and then x2 and y2 or the other way around. But what you want to be doing is you want to pair the respective coordinates. All right. So I like to use the smaller numbers as x1. It's up to you how you want to do it, as long as you're consistent with what you're following. All right. So what I will do is I would say that is x1, y1, and that is x2, y2. I encourage students to develop the practice and habit of actually labeling it, so in that way you can visually see which one's x1, y1. So like I said, you pair the correct coordinates. x1 should be paired with y1 and x2 should be paired with y2. All right. And then when I work that out, what I'll do here is I'm going to go 4 minus 2. So in other words, 4 minus 2 and 12 minus 4. So literally what you're doing is you're subtracting the respective y coordinates over the respective x coordinates. So what you're doing is it's 4 minus 2 over 12 minus 4. All right. And when you subtract, you're going to get 4 minus 2. You put m equals 4 minus 2 is 2 and 12 minus 4 is 8. And then we can simplify that to 1 over 4. So that now becomes your gradient. All right. Please note that the gradient could be a positive number, it could be a negative number, a positive fraction like this, or a negative fraction. All right. So there's no hard and fast rule as to whether gradient has to be only positive. It could take a variety of forms. The first thing you need to do, and again I'm just reiterating, is label x1, y1, x2, y2 like that. And then write down the formula y2 minus y1 over x2 minus x1, and then substitute the following numbers. 4 minus 2 is 2 and 12 minus 4 is 8, and then you simplify that to get 1 over 4. All right, let's move on to question B. I thought just to spice it up, let's put some negative numbers. All right, again, what you do is you allocate your coordinates. That's x1, y1, that's x2 and y2. All right, so in that way you can visually see which one's right, which one's a respective pair of coordinate, and then you write down the formula m is equal to y2 minus y1 over x2 minus x1, and then you substitute. Now please note you've got a negative 3. All right, so that becomes negative 3 minus 4. So negative 3 minus 4, and that becomes 4 minus negative 3. Now it looks very confusing because you've got negative 3 and 4 and negative 3, but please note you got to make sure that you follow the right number, and most importantly in this case the right sign. All right, so what I've done is I've put -3 minus 4 and then 4 minus -3. It's always a good habit to put a bracket just to show that that negative is actually that -3 and not the minus. All right, so what happens when we work that out? -3 minus -4 is -7, and 4 minus -3, if you remember, two minuses put together becomes a plus, so that becomes 4 plus 3, which is 7, and -7 divided by 7 is -1, so the gradient is -1. So you can see the variety of the gradients we get. We get a positive fraction here, we've got a -1. Just one thing to note down, all right, is that you got to be very familiar with your integers, all right? So -3 minus 4, if you didn't know that that was -7, you're going to get the answer wrong. So I always encourage students to follow other subtopics in order to answer this question. As you can see here, you need to know your number line, you need to know your integers very well. All right, now let's look at C. All of them are negative numbers. All right, at times students find that a little bit confusing because you've got negative numbers and then in the formula you got a negative as well, so they're not sure what to do. So here's the trick. Now I'm just going to read it a little bit loud in case you can't see that properly. That's -2, -5 and -4, -2. All right, so I'm going to allocate them the respective coordinates x1, y1, x2 and y2. The next thing, we're going to write down the formula y2 minus y1 over x2 minus x1. All right, and then what we do from here is we work out the respective numbers. So -2 minus -5. So if you see here, -2 minus -5 over -4 minus -2. So it's very, very important to take note of the negative numbers that you put from here. You've got that minus because that's in the formula, and what's in the brackets, the -5 is actually that, and the -2 is right there. So please pay attention with your integers because I've seen a lot of students make that mistake. All right, now you've got -2 and a minus, so that becomes +5, and -4, negative and negative becomes +2. So it's very important to understand, like I said before, when you got two negative numbers together, that now becomes a positive. So -2 plus 5 now becomes 3, and -4 plus 2 becomes -2. All right, so that now becomes your gradient. So your gradient now becomes 3 over -2. So you can see here, you now have a negative fraction. Like I said before, there's no hard and fast rule as to whether you're going to get only a positive gradient. In this question, you had a positive fraction. In this question, you had a negative number, and in this question, you had a negative fraction. All right, just to sum it up, guys, I'll just zoom this properly. When you're solving questions involving the gradient, the first step is allocate x1, y1, x2 and y2. You can even move that as x2 and y2, but the most important thing is you need to pair the right coordinates. Write the formula, because it's always good practice to write your formula here, there, and substitute the numbers. And last but not the least, you need to have a sound knowledge in your integers, especially with these two questions where you needed to know how to work out the subtractions as well. All right, in the next couple of videos, we're going to be talking about finding the midpoint, finding the distance, and also equation of a straight line. Thanks for listening, guys. Bye now.